Alright, hello everyone, welcome to the first video on the Chem Mega Channel. And this video will be just discussing the types of problems that we'll be seeing on Wednesday's quiz, so basically gas stoichiometry and partial pressures. And I'm not going to go over the basic PV equals nRT problems since we already did those a couple months ago. So the problems that we'll be doing here are just the ones from the textbook, the examples, not the technical problems that we did for homework, but some of the other ones that you find just by doing the reading. So in the first problem, you basically are trying to you're trying to convert liters of H2O2 to moles of O2. And as you can see, the problem says, how many liters of oxygen are produced at 78 degrees Celsius and 0.934 atm when 1.27 liters of H2O2 or peroxide decompose? And you're given the balanced chemical equation, as you can see here. So the first step that you'd want to do is, so you're given liters of H2O2, which is over here. So you want to convert that to moles of O2. So what you want to do is use density formula that you're given here to convert to moles. So, or rather to convert to grams first. So you'd go from 1.27 liters to milliliters and then to grams here. And then from grams, you can convert to moles of H2O2 using the molar mass and then convert to moles of oxygen using the stoichiometric ratio found in the balanced chemical equation over here. And from there, you would get 18.7 moles of O2. So now that you have your number of moles, you can use PV equals nRT to find the number of liters. So you'd solve for volume here using PV equals nRT, substitute in the values, and then you would get 577 liters as your final answer. So the second problem involves using a BCA table and mole fractions and partial pressures. So for this problem, you'd really have to understand the relationship between mole fractions and partial pressures, and that they're actually somewhat the same. So basically, the mole fraction ratio will be the same as a partial pressure ratio. So I'm not going to read through this problem because I don't feel like reading the whole thing, and I can't read. So basically, you're given the chemical equation here that's balanced, and you're trying to find, as you can see here, the mole fractions of each of the individual gases in the mixture, and the second part of the question asks for the partial pressure of each one. So what you want to do first is, so you're given you have 1 mole of methane and 4 moles of oxygen, and from there you would set up a BCA table right here. So you're given 1 mole of methane and 4 moles of oxygen. So from there you'd figure out that oxygen was the excess reactant. So you'd set up that all of the methane is consumed and that all of the oxygen, or some of the oxygen, is consumed, and set this up as you can see here. So from there you would basically find the total number of moles using the after row. So basically you're trying to find how many moles of gas are in the final mixture. So that would be 5 moles if you're adding all these up. And so basically you just divide the number of moles in each column here by the total number of moles. So for example, for oxygen, you just divide 2 by 5. So that would basically give you 0.4, and then you do the same for CO2 and H2O. So 2 over 5, 1 over 5, and 2 over 5. So with partial pressures, you have to understand that the partial pressure formula is as follows here. So PA is the partial pressure of one of the gases, XA is mole fraction, and P total is the total number of it's the total pressure inside the container. And in the problem, we're given that the total volume or the total pressure is 1.26 atm. So you just substitute in the formula all the values. So you'd use the mole fraction that you calculated in this previous part of the problem. So for example, for oxygen, you're trying to find P of A basically. So you'd substitute XA, which is 0.4, and the total pressure, which is 1.26 atm as given in the problem itself. And you'd get 0.504 atm. And you just do the same for the other 2 gases. And that's basically it. There's not really anything else you'd have to remember. It's probably just going to be another mathy quiz, and that's it. Okay, thank you.